Alright, as you've already figured out, I am not at school today, but I have made a video for you, and what I'd like for you to do during class today is, first of all, view the video. All I'm going to do during this video is to review the chain rule that you examined last night in your homework, and then I'm going to give you a few more examples, and then I'd like for you to effectively use the remainder of class to work together, making sure that everybody understands the chain rule, because when I come back on Monday we're going to apply this with trigonometry and some transcendental functions. So be focused, take good notes, and let's just kind of walk through this. So again, the objective today is to find the derivative of a composite function, and that uses the chain rule. This, what you see on the screen now, is in your packet on page 4. Hopefully this is going to be clear with the yellow writing. If not, somebody please turn out the lights so you can see a little bit more clearly. But again, it is in your packet on page 4, so please turn to page 4 in your packet. Alright, let me just walk through an example of the chain rule. You can see from the writing on the screen. Let me make sure I have a pen clicked here. Alright, here we go. You can see that the chain rule is used. We talked about this in the other, or I talked about it in the other video. It's used to find the derivative of a composition of functions, and that is a function inside of a function. And the way that you apply the chain rule is that you multiply the derivative of the outside function. Remember, I talked about that as the number 1 by the derivative of the inside function, and that's what I talked about as the number 2. So it's outside times inside. So in an example, I've given you a function in terms of theta. It is the square root of 5 theta squared plus cotangent of theta. So the first thing that we're going to do is to take this and rewrite it into a power function so that we can see the inside function, and the inside is literally on the inside of the parentheses. I did it again. The outside function is the number 1, so that is the power. The inside function is the number 2, which is inside of the parentheses. So we're going to deal with the outside function first, which is power. And again, I've done the same thing here. My outside function is the power. My inside function is the angle itself. I know that's not very clear, but it is in your packet, and I'll try not to use this background and these colors anymore. So finally, we want to apply the chain rule, and notice what I've done. I've made it very clear. We're using the power rule, so we bring down the 1/2, leave the inside alone, it comes for the ride. I talked about in the video yesterday, and then we're going to decrease the power by 1. And all of that, as you can see, that's the derivative of the outside. Step number 2, so this is the number 1 step, this is the number 2 step, the derivative of the inside, which is easy. Now, don't be confused by the variable theta. Theta is treated just like x. So when we find the derivative of 5 theta squared, we get 10 theta using the power rule. And the derivative of cotangent theta is negative cosecant squared theta. And so that's the derivative of the inside. And the only thing that I could do here, if I wanted to, is I could clean this up by leaving 10 theta minus cosecant squared theta. There's already a 2 in the denominator from the 1/2, and I could move the other expression down and make it a square root to make that power positive. But at this point, it doesn't really make the answer better or worse, because so far we're not really doing anything else with that derivative. Alright, let's do a few more examples, or let me do a few more examples for you, and then you're going to have the rest of the class period to work on some more problems in small groups, and make sure that nobody leaves without knowing how to apply the chain rule. Alright, so here we go. Problem number 1. We're trying to find the derivative of all of these, and we have a series of things going on here. So first of all, notice that my function is in the denominator, so I'm going to apply a rewrite. And I'm going to change this into x squared plus 2 raised 2. Now we're moving it to the numerator, so we have to make the power negative to the 2/3 power. So we're going to identify inside and outside. So my outside is the power, my inside is x squared plus 1. According to the chain rule, we're going to take the derivative of the outside. So we're going to do the power rule. Negative 2/3 of a quantity, decrease the power by 1 to the negative 5/3. And again, remember what we talked about. The inside just comes along as a part of that expression. And then, step number 2, we multiply by the derivative of the inside, which in this case is just 2x. The cleanup of that would be negative 2 times 2x in the numerator, so there's the negative 4x. In the denominator, we have a 3, and then I'm going to move the other expression back down and give it a positive power. So that's not really so bad in cleaning that up. All right, let's take a look at problem number 2. Number 2 is kind of interesting because there are two things going on. Now, as we get into more complex derivatives, you have to analyze the situation and decide which tool is the best tool for the job and what do I have to do first. Now, I can see that there is a function inside of a function, but before I examine that, I notice that the entire expression is a product. So there are two things that I have to do. First of all, I have to apply the product rule because I'm dealing with a product, and then within the product rule, I'm going to apply the chain rule. So you got to be careful. So here we go. We're going to apply the product rule, and then we'll jump in. While we're doing the product rule, you'll see how we'll hit the chain rule. All right, so this is my, let's change colors. This is my first function, x squared, and this is my second function, square root of 1 minus x squared. And let's go ahead and rewrite that as x squared times 1 minus x squared to the 1/2 power. All right, remember, product rule first. So we have the first times the derivative of the second. Now, when you do the derivative of the second, that's when we're going to apply the chain rule. Okay? So in doing the derivative of the second expression, the outside is 1/2. The inside is 1 minus x squared. Chain rule. Power rule, 1/2 of the quantity, 1 minus x squared, decrease the power, times, that's the derivative of the outside, multiplied by the derivative of the inside. All right, now all of that was the derivative, the first times the derivative of the second. All of that was the derivative of the second. I had to apply the chain rule to get the derivative of the second. All right, now go back to the product rule. Plus the second expression, and my second expression is 1 minus x squared to the 1/2 power, times the derivative of the first, which is 2x. Now, in terms of cleaning, all we're going to do is take this x squared and multiply it by the negative 2x that we have back here, because all of this is multiplication. I'm also noticing that this 2 will divide out with this 2. So in the numerator, for the first term, I'll have negative x cubed over the square root of 1 minus x squared. And you guys can help each other out with figuring out what's going on with that algebra. And in the second expression, I will have plus 2x times the square root of 1 minus x squared. And no, you cannot cancel this square root with this square root because there's a big fat plus sign in the middle. We could get a common denominator, and there may be a time when we actually have to get a common denominator and do more with this derivative. Don't be freaked out. Just remember, we were doing the product rule, and while we were doing the product rule, when we found the derivative of the second, we happened to have to apply the chain rule. So again, right tool, right job. And finally, problem number 3. Let's go back to red. This is the granddaddy kind of them all. We have an outside function, which is our square, and we have an inside function, which is a rational function. But if you're like me, you're noticing something, that the inside function is a quotient. So when we find the derivative of the inside, we're going to have to do the quotient rule. Right tool for the right job. So here we go. The derivative of the outside, so we're starting with the chain rule because this is the outermost function. Back over in the other problem, before we had to apply the chain rule, it was a product. So you have to go in the right order. Alright, so here we go. The derivative of this function would be, I'm doing the chain rule, and I'm going to do the derivative of the outside. The outside is a power, so I'm going to do the power function 2 of the quantity decrease the power by 1. Again, I know that you don't have to write that, but I'm doing it for sake of your notes. So that's the derivative of the outside. Now we're going to multiply that times the derivative of the inside, and that's where our fun begins, because the derivative of the inside is, let me write this, that's the derivative of the outside, by the way. So we did the power rule. The derivative of the inside is a quotient, so we have to do the quotient rule. So I'm going to put a big bracket. Alright, quotient rule. Down, D up, minus, up, D down, over, down, down. Alright, so the derivative of the outside and all of this was the derivative of the inside, and the way that we had to find the derivative of the inside was using the quotient rule because the inside was a quotient. Alright, let me look at that and see what we can clean up here. I'm going to hold the 2 out for right now, and I'm going to leave this as 3x minus 1 over x squared plus 3. In the second expression, I'm going to go ahead and do some distributing, so I get 3x squared plus 9. If I make any arithmetic errors, you all can clean it up for each other. 6x squared, because you're not there to help me out right now. 6x squared plus 2x over x squared plus 3 squared. Cleaning that up, let me erase this down here because I'm going to need the space, I'm pretty sure. Alright, so cleaning that up, I have y prime, or the derivative, equal to 2. Still going to leave that out for now. 3x minus 1 over x squared plus 3. Isn't this fun? So 3x squared minus 6x squared gives me negative 3x squared plus 2x plus 9, I think I got everybody, over x squared plus 3 quantity squared. We could distribute the 2 in. I mean, now we're kind of getting to the point, I don't know how much good this is doing, but let's go ahead and make this 6x minus 2 times the quantity, and we're not going to multiply that out, negative 3x squared plus 2x plus 9 over, now notice in the denominator I have x squared plus 3 to the first power here and x squared plus 3 to the second power, so that would give me x squared plus 3 to the third power. And that's where I'm going to leave the problem for now, because mainly I just want you to practice the various rules. Okay, what I would like for you to do, I don't know if I wrote your, yes I did, good job. Your assignment, and you're going to get a worksheet. This is from your textbook, but I copied the problems for you so you could start working in small groups. Page 161, 10 through 36 even, number 111 and 153. There are also, again, I'm going to keep reminding you, there are several Patrick videos on my Edline page if you just want a different perspective, or you want to see additional problems. So now for the remainder of the period, I expect you to be working until the bell rings, getting as much of this done as you can. And I will see you on Monday. Have a good weekend.